The first one we're going to talk about is symmetrical encryption. And just as a reminder, encryption is a way to hide or essentially jumble up a, let's say, piece of text into something that it's impossible for a third party or someone to read without some sort of a way to decrypting it. So it's a way to have secrets. Now, symmetric encryption uses one secret key for both encryption and decryption by both parties. Let me show you what I mean. If I wanted to send hello as a message to this other computer, using symmetrical encryption, I can have a key that turns this hello text into a piece of gibberish. And as long as my friend or my other computer has the same key, I can use this to decrypt it and get hello. And who's ever in the middle here, whoever is in the public over here reading our message, won't understand what we're saying to each other because they don't have this key. So again, with symmetric encryption, anyone who possesses a key can decrypt the message being transferred. And SSH communicates through this shared key, and that's how we are able to talk to one another. That's how I was able to talk to DigitalOcean with that server. Okay, awesome. This looks nice, but what is one problem you notice here? Can you think of any? Well, anyone that has the key can decrypt the message. So if I was sending my password over to this other computer instead of just hello, something really, really important, if somehow Mr. Bad Guy happens to find the key or also know this key, he or she can find out my password. He can decrypt this message just by using the same key as us. So we have to get this key in a secure way so that other people can't use it as well, or can't find out what it is. And this is done through what we call a key exchange algorithm. A secure way to exchange these keys without any bad actors intercepting it. And what makes this algorithm particularly secure is the fact that the key is never actually transmitted between the client and the host. Instead, the two computers share public pieces of data and then manipulate it to independently calculate the secret key. So even if another machine captures the publicly shared data, it won't be able to calculate the key because, well, this key exchange algorithm, which for now it's kind of like this magical purple box, is not known. So without them having this key exchange algorithm, they won't be able to ever find out what our yellow key is. And don't worry, we're going to talk about this in the next video and how this is done. But it must be noted that the secret key is specific to each SSH session and is generated prior to something called client authentication. So once the key has been generated between these two parties, all packets moving between these two machines must be encrypted with this key. So using symmetrical encryption, we're able to communicate in a private way, but it looks like we need to do some sort of a key exchange here. And in the next video, we're going to talk about exactly how we do that. I'll see you in that one. Bye-bye.